Okay, so today we're going to work on multiplying fractions. So our warm-up is just a review of subtraction and a review of multiplying integers and then a review of cross-cancel. So pause the video and complete the warm-up. And then when you're ready, go ahead and push play and I will go through the answers. So the first one is a review problem. So we're just evaluating a subtraction problem, so we need to keep in mind that we need a common denominator. So 4 and 14, well, I know my multiples of 14 are like 14, 28, and I can stop there because I know 4 times 7 is 28. So 14 times 2 over 2, 3/4 times, I need 7 over 7 to make common denominator. So this will be 2 and 14, 28. Take away 3 times 7 is 21 over 28. And so I might change this into having just my integer problem on as the numerator, so it's easier to see. I need to do 2 take away 21, which is going to be negative because there's more negatives. And so it will be negative 19 over 28. Alright, now moving on to simplifying integers. Remember to take your time so you don't mix up a sign, and just go left to right like you normally would. So 3 times negative 1, negative 3 times negative 1 is positive 3, and copy and paste the rest. 3 times 8 is 24, copy and paste. 24 times negative 2 would be negative 48 times negative 4. So negative times negative is positive, and then 48 times 4, 8 times 4 is 32, 4 times 4 is 16, 17, 18, 19. 16 plus 3 is 19. So negative times negative is a positive 192. So all you're worried about is your symbol. All of you are good at multiplication. You just need to watch out and make sure you get the right sign. And the other thing you can do is count your signs in the beginning. It's negative and a negative is a positive, a negative and a negative is a positive. There's no leftover negative, so you're going to get a positive number. And whatever way works for you. Okay, cross-canceling, remember, means what we're really doing here when we cross-cancel is to look for simplifying across fractions. And the reason we're allowed to do that is the commutative property. I could really write this, I could do a whole lot of mixing up of this problem. So if you remember how to cross cancel, you can just go ahead and do it. But here's the why. So if I wanted to, I could mix this up, because it's really just 18 over 25. 18 times 25 over 5 times 24. And then I can rearrange, because I want the 5 and I know the 25 and the 5 will cancel. So using my commutative property, I would rearrange so it's 25 times 18 over 5 times 24. Let me fix my 5. It didn't work out very well. Okay, and now I can just simplify each little fraction. So the reason is because you're allowed to do commutative property allows you to change things around, and of course we don't need to actually do this work since we know the commutative property. This is kind of what we know, and we can go ahead and just cross cancel. 5 divided by 5 is 1, 25 divided by 5 is 5, and it's always a top bottom type thing, either top and bottom, up and down like over here, or top and bottom across. Okay, 18 and 24, they have a 6 in common. So 18 divided by 6 is 3, 24 divided by 6 is 4. And now you could multiply it straight across and you have much nicer numbers to work with. Okay, let's review multiplying fractions. For multiplying fractions, you do not need common denominators. And why is that? Why don't you need common denominators when multiplying fractions? I'm going to show you kind of why in a visual model. You have to think about what this says. I mean, I can read that 1/4 times 2/3, but that's just kind of reading what I'm seeing. And comprehending it would be, I want 1/4 of 2/3. Or remember, fractions are just talking about a portion of something. 1/4 of an Oreo cookie is tiny, where 1/4 of a pizza is giant. So it's really just part. I just want part of 2/3. Okay? So I want exactly 1/4 of it, of course, but I'm just thinking of a part of one thing. Versus earlier, when I was adding, oh, you know what? It's deleted. But when I was adding, you're combining two things. I'm combining, Susie's Oreos and Johnny's Oreos, and now I have this many Oreos. But here, I'm just taking part of one thing, part of a brownie, part of a cake, part of a pizza, something, one giant thing. Okay, so looking at that in an area model with a picture, the first thing I'm going to do, since I want part of 2/3, I'm going to start by drawing 2/3. You can start with either fraction, but just because of the way I wrote it. So first I'm going to draw a hole and split it into thirds, and then I have 2/3, so I'm going to highlight 2 of those. Get them all colored. Okay, so now I have 2/3. Well, I want to know how much 1/4 of those 2/3 are. So really, I'm ignoring this blank spot, this blank one, because I don't actually have it. It's just kind of part of the fraction. So what I need to know is how much is 1/4. Well, to do that, I can just go ahead and separate my area model here into fourths. So you can see I have 1, 2, 3, 4 pieces. And I want to know how much 1/4 of 2/3. Remember, the 2/3 is the yellow part, so how much is 1/4 of that? Well, if I highlight 1/4, let's see, I want this color. 1/4 here. Oh. I want to know how much 1/4 of 2/3 is. Well, 1/4 of the whole thing is the blue. 2/3 of the whole thing is yellow, but I want to know 1/4 of the 2/3. Well, that's where they're overlapping. That's 1/4 of the yellow part. So what is that? What's the answer then? Well, you have two things, so your numerator is 2. But what's the size of the pieces? Well, we've now cut this up into a whole bunch of things. So the size of this is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 2/12 that I now have. Okay, so I don't need a common denominator because I'm really just kind of chunking, maybe a big cake. I only have 2/3 of it left over, but now I want to give 1/4 to Grandma or something. So I give Grandma 2/12. Now, of course, you probably would never go, hey, Grandma, here's 2/12 of cake, but that's the idea anyways. You're taking a part of a part of something. Okay, so it gets a little tricky when you try to explain it in words. But it's one thing versus two combining things. All right, now let's go over our review examples. In your foldable, you have examples from last year, so this is just 2 more. You could add them into your folder if you have room or on your notebook, either way. So remember, the first step in fractions, or any fraction problem, is to change things to improper so that you can work with all of your parts and not all mixed numbers. We don't want mixed forms. So I'm going to take my 3/8 and multiply it times, this is negative. I'm going to make my negative really big so I don't lose it. Let's see, 1 times 3 is 3, 4, 5 thirds. Okay, now I'm going to, I can check for cross canceling, or if I don't care so much because these are small numbers, I can just multiply, but I always like to simplify right away. Because I know 3 divided by 3 is 1, 3 divided by 3 is 1, so it's 1 times -5, or however you want to do this. You can think of it as a -5 or a -1, but not both. Or you can just think positive times negative is negative, and then just do your numbers. 1 times 5 is 5, 3 times 1 is, 8 times 1 is 8, so your answer is -5/8. Okay, so remember that negative in front of the 5/3, it goes up, it's one number, so you can only use it one time. And you can use it when you think about positive times negative, or you could put it on one of your numbers because it's one number, not two numbers. So one or the other. Because if I did negative, if I did on both, that would be negative over negative, which is positive. So one time you can use it. All right, doing one more problem. 5 1/4 times negative 2 1/3. Sometimes I think about my sign right away. Positive times negative, definitely going to be negative. So somehow you could even write the word negative so you don't forget. Figure out your answer. Okay, so change these into improper. 5 times 4 is 20 plus 1 is 21 over 4 times negative 2. So I just know this is negative. So I'm going to squeeze that in there because I ran out of space. 2 times 3 is 6 plus 1 is 7 thirds. And now I already know it's negative, so I'm just working on my numbers. So let's see. Cross cancel. Can I cross cancel? 21 and 3. So 3 divided by 3 is 1. 21 divided by 3 is 7. And now 7 times 7 is 49. 4 times 1 is 4. And I know it's negative, so I'm going to put that on there. Okay, so what's my answer? Well, I don't want to leave it as an improper fraction. So 4 goes into 49 12 times. So negative 12 wholes, and how many are left over? 1/4. So negative 12 and 1/4. Okay, you can go ahead and start your homework.